Throughout our research, we have found several real-life graphs. One of these shows the global consumption of gas each year since 1980 until 2016. It has a domain of 1980 to 2016 and a range that goes from 53 million to 132 million. Our independent variable are the years, and the dependent variable is the amount of consumption. This graph is type ascending and it does not show any trend. Another graph shows the accidents from 1997 to 2015, the number of deaths and injuries per year. The domain goes from 1997 to 2015 and the range goes from 98,435 to 159,210. The independent variable are the years and the dependent variable are the amounts of deaths or injuries. It is an ascending type of graph and it does not show a trend. Another graph shows the world consumption of coal through the years. The domain goes from 1980 to 2016 and the range goes from 4,124,597,785 to 9,045,027,366. The independent variable are the years and the dependent variable is the amount of coal bought. It is an ascending type of graph and it shows no trend. Another graph shows the global water use. Its domain goes from 1901 to 2009. Its range goes from 671,306 to 4,072,946. The independent variable is the years and the dependent variable is the amount of water. The type of graph is ascending and it doesn't show any trend. Our last graph tells us the total estimated circulation of US daily newspapers. It has a domain that goes from 1940 to 2018 and a range that goes from 32,371,000 from 63,147,000. The independent variable are the years and the dependent variable are the amounts of newspapers sold. The type of graph is both ascending and descending and it does not show any trend.
Well, most of our data was taken from this international section. Why? Because most of these graphs and data are in this section, but it's not because it is not useful in other sections. For example, in the sports section, you could use these data and functions to present some statistics of the players or something like that. It is not specifically from international section, but they use it more because they based their content on facts and data worldwide. This type of content. So yeah, and when we were changing our main function, that was this crashes and injuries through the years, well, we find out that there are different uses for the different types. For example, in the coordinate plane graph, well, it is much easier than in the table graph to see where it increased the rate or decreased the rate of the crashes and injuries in the years. However, in the table, we can have more exact data. If we really want to get the exact number, well, it is harder to identify, but we can get this real difference of real number. Then we have our equation to see more or less our graph move. Well, we got a 90% of an R2 of 90%. It is not that exact, so it is not that precise of a use, but it could work a little bit. It is not the most precise thing.
Explain what information the function provides. The amount of deaths and injuries on crashes per year. Explain how the value of the function depends on the independent variable. The amount of deaths and injuries on crash of that year depend on what year we are referring at. Identify the type of function, linear, quadratic, or otherwise. In this case, it's a quadratic. And then identify some properties of the function such as minimum intervals in which it's increasing or decreasing, if the variables are discrete or continuous, etc. The maximum value is 159,210, and the minimum value is 98,435, and it's an increase and decreasing graph, and the variables are discrete. They in fact did present the information in the most convenient way possible due to the fact and they gave us the exact amount of deaths and injuries per year in the same graph, showing us the increase and decrease per year.